Okay, welcome back. We're looking at average rates of change. That's our topic today. Let's just define what that is, and then we'll look at some applications to this. So you guys can see here, average rate of change is just the average, kind of, if you want to think of it, it's honestly just the average slope of a line that's not linear. It's the average change in the between the y's over the x. So you guys can see this. If I've got an ordered pair that's xy and another one that's xy, to find the average rate of change, I'm just going to do my y2 minus y1, so the difference in my y values, and then divide it by the difference of my x values. This is the same formula for the slope. It's because if you look at this graph right here, so for example, if I was finding the average rate of change for this graph that's quadratic right here, so our parabola here, from 1 to 3, 1 is right here and 3 is right here. That line is not linear, but we can think of the rate of change, or the average rate of change, as a linear slope. So we're just going to find and plug in 3 because that's my second value for x, and that gives me 9, and then I'm going to plug in 1 for x squared, so that gives me 1. So that's where I get the 9 minus 1 here. And then I'm going to divide it by my x2 minus my x1. So y2 minus y1 divided by x2 minus x1. That gives me 8 over 2, which gives me 4. And so the average rate of change of this curved line is 4. That's what the average, you can kind of think of it as a slope in a sense. It's just like an average slope, but we call it a rate of change. So that's what rate of change is. What I expect you guys to be able to do is take equations and then an interval and find that average rate of change for that. If you have a linear equation, guys, remember linears are always going to have the same rate no matter from what point to what point. And so it's just whatever the slope is. So everything we're dealing with is right now is going to be non-linear right here. So I want to find my average rate of change for this here, these two. So if I look at this first one here, this equation right here is f of x equals x squared minus 3. And then these are my x values. This is saying that this is the first x value and this is the second x value. It's not an ordered pair. These are just telling you from x negative 2 to x negative 1. And so to find my y values, like for example, to find y1, I'm going to plug in x1 for my equation. So I'd go negative 2 squared minus 3. That'll give me 4 minus 3, which will give me 1. So y1 is 1. Then to find y2, I'm going to plug in x2. So I'll have negative 1 squared minus 3. Square that will give me 1 minus 3, which will give me negative 2. So these are my y1 and my y2. And then I can just apply my equation right here to find my rate of change. The difference of my y's minus the difference of my x's. So I'm going y2, so negative 2, minus y1, which is 1, all over x2, which is negative 1, minus x1, which is negative 2. And then just simplify. So this numerator should give me negative 3. The denominator, I've got negative 1 minus the negative comes plus. So that's negative 1 plus 2, which will give me a positive 1. So my average rate of change is 3 for that one. And again, that's going to be a parabola. So that just tells you that the average rate is going down from left to right. So again, if you were to look at this graph, it's very similar to this graph, except for it's been moved or shifted, but it's going like from negative 2 to negative 1 is essentially what it's doing right here, is this slope. Okay, look at this. This was a rational function, but this is telling me to find that average rate of change from x1 to x2. x1 is 5, x2 is 12. So to find y1, I'm going 5 minus 3. I'm just going to plug in, again, plug in for where I see x. I'm going to put 5 in for that. So 5 minus 3 all over 5. And so this is going to give me 2 over 5. Okay? And then to find my y2, I'm going to go 12 minus 3 over 12. And so that's going to give me 9 over 12, which that simplifies to 3/4 is what that simplifies to. So now I'm ready to use my my formula, the y2 minus y1. So I've got 3/4 minus 2/5 all over x2 minus x1, so 12 minus 5. The denominator should be really easy. That's just 7. My numerator, I'm going to actually have to subtract and get like common denominators. So I'm going to times this by 5 over 5, which that's going to give me 15 over 20. And then this one's going to be 4 over 4, which is going to give me 8 over 20. And then I can just subtract those. So 15 minus 8, which would give me 7 over 20 here. So I've got 7 over 20 divided by 7, and this is just over 1. Don't forget that. When you divide fractions, you can actually flip the denominators 1 and times it. Oops, we actually flip this, so let me erase this. So that should look like, going up here, that should look like 1 over 7, which that just gives me 7 over 140, which these 7 just cancel out, which gives me 1 over 20 is what that gives me. That's what my slope would be for that. So a really small positive slope on that one. So I give you one that, like I say, involves a little bit of fractions, but the idea is still the same. You just find out what your y2 and your y1 are, and then just use your formula, the y2 minus y1 all over x2 minus x1. You might want to write this down. That's my formula for my rate of change. Okay. If you're looking at a graph, it's a lot nicer because I've already got my values here. So I've got my graph here, and this is saying find the average rate of change from 1 to 3. So at 1, it is right here. At 3, my graph is right here. And so I want to know what my slope is essentially from this point to this point. So all I've got to do is see what my difference of my y's is. So the difference for my y is from 0 to -4. So this would be your, so this point is 1, 0, and this point is 3, -4. So again, I can go my y2 minus y1, that'd be -4 minus 0, all over my x2 minus x1, which is 3 minus 1. And this is going to give me -4 over 2, which is going to give me -2, would be my average rate of change. So on a graph, you already have your points. You don't actually have to find them. You just got to say, hey, here's this point, here's that point from 1 to 3 in my x values. Okay? And then last thing, story problems here. And this is, again, you'll always need a y2, a y1, an x2, and an x1. We just got to find those points. So here we've got, according to a census, figures the population of Clovis was 31,194 in 1980, and then 32,511 in 2001. So probably the best thing, or you don't have to do this, but I think this might be a little bit easier. Like this is year 1, think of that, and then I just need to figure out how many years it is from there, which that would be 21 years from 80 to 2001. And then this is going to be your x1, and this is going to be your x2, the years, which means this is my y1, and this is my y2 for that. So for this one, I'm just going to go my y2, so 32,511, minus my y1, 31,194, and I'm going to divide that by, again, you could just use the years if you wanted to as well. That's not a problem. Or you can think of it as this is the initial year and to there. So, but either way, you can think of it as one way or the other. I'm just going to go 21 minus 1 here. actually, sorry, mine is 0 because this is the beginning. So, okay, and then I just need to subtract those values, and so let me do that really quick. I need to subtract my numerator first. So we are going 32,511 minus 31194. That gives me a value. Gives me a value of 1,317, and then divided by 21, and so I can divide that, and when I do that, I get 62.71 when I round. So that's my average rate of change. I'm increasing my population on average year to year by 62.7. So we'd say probably 63 people is what we'd go to with that one. So, all right, this is it. That's been your Math Moment with Mummy. Adios.